Today, I'd like to introduce the application of passive surface method using seismic ambient noise to delineate 3D SA velocity structure at South and East San Francisco Bay Area. Left-hand side is the site we carried out active and passive surface measurement or array measurement. We have dispersion curves at these 62 sites. Right-hand side is the site we measured H over V. We measured H over V and 166 sites. To build the 3D velocity model, we used H over V, dispersion curve obtained from array measurements, bedrock depth H over V relationship obtained from array measurement, VS30 information at about 100 sites obtained from active and passive surface methods, downhole or cross-hole seismic logging collected by USGS, and deep 3D seismic velocity model based on geological information compiled by USGS. You can take a look at all our measurements at our website seismeasure.com. Left-hand side is the VS30. It includes USGS database as well. The VS30 is about 150 meters per second along shoreline and increases in the landward direction. VS30 exceeds 300 meters per second at Coyote Hills and on the northeast side of the Hayward Fault and southwest side of the San Jose. Right-hand side is H over V peak frequency. Different color indicates different peak frequency. Red to yellow circles indicate low peak frequencies that corresponds to deeper bedrock site. And green to blue circles indicate high peak frequencies that corresponds to shallow bedrock sites. At the site we carried out array measurement, we calculated dispersion curves and estimated VS profiles using joint inversion together with H over V. We summarized the relationship between H over V peak frequencies and bedrock depths obtained from array measurements. The site we only measured the H over V, we constructed initial velocity model based on VS30 information, geological information, and bedrock depths estimated by H over V peak frequency, then applied inversion to estimate VS profiles. This figure summarizes relationship between H over V peak frequencies and shallow 760 meters per second and deep 2500 meters per second bedrock depths obtained from this study. It is clear that both shallow and depth bedrock depths increase as frequency decreases. Regression line broken lines for two bedrock depths are used to generate the initial 1D profiles of the inversion at sites only H over V measurement was performed. This figure compares VS profiles obtained from this study with the 3D velocity model mainly based on geological information compiled by USGS. At the South Bay, depth to a layer with VS of 2000 meters per second was approximately 1900 meters and 500 meters at Cupertino and Alviso respectively. At the East Bay, depth to a layer with VS of 2000 meters per second were approximately 600 meters and 900 meters at Fremont and San Leandro, respectively. We can say that the VS profiles obtained from H over V and array measurement were reasonably consistent with the 3D velocity model based on geological information. We combined all 1D VS profiles and interpret to a 3D velocity model. Left-hand side is the interpolated VS30. Here is the Coyote Hills and Hayward Fault. It ranges 150 to 500 meters per second and lower at shoreline to middle of South Bay and higher at mountainside. Right-hand side is the shallow bedrock depth, the top of 750 meters per second. Here is the Coyote Fault and Hayward Fault. Depth to the shallow bedrock ranges 20 to 400 meters, and it is generally deeper at South Bay compared with East Bay. At the South Bay, the bedrock is deeper at Cupertino and Evergreen Basins. It is shallower along Silver Creek Fault to Coyote Hills. Left-hand side is VS at 400 meter depth. Here is the Coyote Hills and Hayward Fault. We can see VS is generally lower at South Bay compared with East Bay. Left-hand side is VS at 700 meter depth. Here is the Coyote Hills and Hayward Fault. At South Bay, VS is relatively higher at middle of a valley from downtown San Jose to San Jose Airport and Alviso. The high-velocity ridge in the South Bay appears parallel to the Silver Creek Fault and may continue northwest to Coyote Hills. Now I take a look at cross-sections at South Bay. Here is a cross-section from Menlo Park to San Jose. The shallow bedrock is clearly shallower at Alviso and deeper at Evergreen Bays. Here is a cross-section from Cupertino to San Jose. The shallow bedrock is clearly shallower at SJC and deeper at Evergreen Bays. Here is the conclusions. Note that the 3D-VS model is a preliminary model. More geophysical measurements are needed to delineate basin structure in greater details. Thank you very much.